Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to another edition of the Smart City Podcast. Today, I'm thrilled to be joined by Ted Connell of Blue Skies AI. Welcome, Ted.
Thank you very much for having me.
It's great to have you here today. Ted, let's get started by, let me ask you a little bit about your background and how did you come to the world of AI?
Great question. So I started as a process engineer in the stainless steel industry. So I've lived the life growing up in the industrial sector. But AI really didn't come to being till around 2010 with IoT and such. What happened in around 10 years ago or so is we got enough compute, enough storage at low enough cost that people like iPhones and television sets could start pooling AI into their business. And the early people to do it were the consumer electronics players. And my career had progressed. I was with IBM in the service business, and I was working with a lot of the consumer electronics players, trying to understand how do we leverage these new technologies, what do we do with them, and how do we make money with them. So 10 years ago, I was working on the Smart TV Alliance when we were connecting TVs and putting platforms together. And it's just progressed towards that. So I've been in the ecosystem most of my career, and AI for the last 10 years or so is really, I think that answers your question.
Okay. What are the challenges of AI? And perhaps even before you answer that, for those of us who might not be steeped in the technology, what really is AI?
That's the greatest question.
Let's just start with that.
Because most people out there think of AI, they think of the Terminator and Arnold Schwarzenegger blowing everything up. And what they were describing there is consciousness. What AI is math. It's not scary, it's just math. And it's like plastic and it's like electricity. AI is going to go everywhere because it makes everything better. So think about your brakes in your car, your ABS brakes. Remember when we got ABS brakes? I can now put a couple dollars worth of electronics in there and make your brakes a lot better because they're measuring how hard they're pushing and they're deciding when they want to push depending on what you're trying to do and how hard you're pushing your brake pedal. But we can make your brakes better. There's no consciousness in there. It's just a mathematical equation that's watching a pressure here and a pressure here and a temperature, and it's doing a mathematical calculation to say what's the optimal. So that's all AI is. It's just math trying to optimize equations.
Okay, so now let's move on to, there's been great hype about AI in the world that it will be deployed everywhere.
Yep.
Some of that is overhype.
Yep.
Some of it is true. So what are the challenges of AI today?
Great question. Today, it's very hard in the industrial sector. You want to focus on the industrial sector? Let's focus on our industry in the industrial sector. Today, AI is very hard because most of the data is siloed. Most of the data is not in a system like the IT systems that you can network it together. And so the first problem is just getting the data you want, and that's very hard. Once you have data, you have to go through a long process of labeling the data. What am I looking at? And that takes a lot of time. And then you have to train models with all these big datas. That's the state of the state today, but that's not where we're going to be in tomorrow.
So just to review, siloed data.
Yep.
First we need to aggregate the data.
Yep.
We need to label the data, perhaps with a common data model.
So not only that, but let's say I'm looking at an image. I have to label what is in the image. What is this? Is this a dog or a cat? Is this a defect or a good part? So I have to understand what the data is I'm looking at.
And then, lastly, we need to create some mathematical model to improve that situation upon which we're thinking about.
And the timeline could be that the mathematical model takes 10% of the time, and 90% of the time is getting the data and making the data useful. So the training is not necessarily the problem. Now, the training can take weeks, but getting the data can take a lot longer.
Certainly. I'm intrigued because my initial thought was, particularly in the industrial world, the models, there may be a plethora. There may be innumerable amount of different models for industry-specific processes, or even manufacturer-specific patented processes, secret sauces, whatever. But that is all just coding, which could happen quite quickly once you have this data repository upon which to act.
Yeah, so absolutely. So if you're a company, you're going to go through a digital transformation to get the data out of the silos, make the data available on some kind of network so that you can feed these engines. So that's one path, and this conference is talking a lot about that. The ARC Forum is talking a lot about that here, in 2022 here in Orlando. That's a big theme, and it should be. There are other ways to get AI to work today. So AI is working on your phone. Right now, if you pick up your phone, AI is working on Facebook, it's working on Google, it's working on all those apps that are not necessarily on your phone, but they're in the cloud. So today you can apply appliances that are standalone solutions that can do AI for you. So because of COVID, a lot of people were doing AI to say, are people wearing their masks? Personal protective equipment. You can't walk into the school unless you have a mask on or something like that. So a lot of people applied AI to do things like that, and they did it on a PC. So because the technology is advancing and because compute is becoming so powerful, we can now run AI on literally laptops and phones. So the technology is changing. There are opportunities. Now, if you're an industrial company, you might not be able to optimize your whole process because you don't have the data from all of your process, but you can drop an inspection solution in there. You could drop a predictive maintenance solution in there. You could, there are all ways to do it. You can monitor your electricity with tools and reduce your, with AI and reduce your energy input. So, with smart buildings, you can monitor people coming into the building, know when people are in rooms and change temperatures around and things. There are things that you can do that have economic value, but the big win is when you get what we've talked about, undo these siloed data, open up the data, and when all that's flowing, then you can optimize your whole business. But that's a journey.
Yeah, indeed. And if you do have that common data repository, the applications you can imagine, are ones we cannot imagine today. Things will be created that we couldn't have imagined. Just like the phone created a range of different things that we could never have imagined before.
Absolutely.
Let's go back. You mentioned digital transformation.
Yeah.
And let's focus on perhaps the deployment issues around AI. Digital transformation has three pillars. The first being the technology itself.
Yep.
The second is the business processes that change because of that technology deployment. Mm-hmm. And then the third is the people that are required to embrace both that technology, maintain it, operate it, service it, as well as support those new business processes that may have been unseen in the past. So, is AI fundamentally different than some new tool set that someone might get at their industrial job, or is it just another tool?
It's a tool set. At the end of the day, it is a tool set. And, remember a generation ago we went through Lean Six Sigma? That's a good benchmark for how you go through digital transformation.
Indeed. So you're at your organization. Is Blue Skies AI.
Yes.
What does Blue Skies do?
So we're a spin out of Intel. We've been partnering with J&J for the last couple of years because J&J had a inspection problem. Quality is everything in pharmaceuticals, and they're using human beings to inspect product. And that's across the industry, so it's not just this company. And human beings cannot concentrate for 8 hours straight. We have to have bio breaks. We can't stop the line. It's a job that is thankless, and it's very, very difficult. I started, as I said, as a process engineer. I've worked with inspectors. Not only is it a job that you can't do, so you have a low self-esteem because you can't physically do your job. When you find a defect, you have to go tell the person who made a defect that they did something wrong. So it's not a fun job. And as you know, in the industrial world, there are not enough industrial workers, so we're paying people to do a non-value-added job of inspection where we really want to apply them to a value-added job and move them where they can do, not only feel good about themselves because they're doing a job they can do, but they're adding value to the company. So I built a company to use AI to replace the human to do inspection in pharmaceutical. And we run it on Intel Core i5. Commodity, off-the-shelf hardware. The whole model was, we had to do something that's effective, got to work, and we're 99.999+% efficient, so far greater accuracy than human beings, and we had to do it to scale. So J&J has plants all over the world, 400 plus plants. Each plant has a different skill set, but each plant will have a process engineer and site services. So all you have to do with our product is install it, which site services can do, show it the gold standard of your inspection, which every company has, just how you decide this is good or this is bad. Show it those examples. The tool trains itself. You don't need to program. You don't need to know AI. So we built a spot solution that solves an immediate problem for our client, and we're just now launching it to the world. So we're really excited to be here at the ARC farm. We've had great conversations with people, and the good thing about the ARC farm is you get industries together, and we were talking about digital transformation. Johnson & Johnson, when they started their digital transformation effort, went out and benchmarked best of breeds. And that's how I was introduced to them, is they wanted to benchmark the Intel factories. And Intel will let you do this. And I advise anybody, if you're thinking about digital transformation, talk to Intel. The reason is the factory in Chandler, Arizona, and there's only a little bit I can tell you about it, but it's building to the manufacturing process is building a wire in all their electronics that are 10 atoms in diameter. 10 atoms, or 10 gold atoms in the whole wire. How do you do that? This is manufacturing at the atomic level. So that factory goes through a petabyte of data every day with billions of endpoints talking to each other. That's how they do it. So they've gone through this digital transformation because they had to make that integrated circuit. So I would benchmark Intel. They have some best practices, and J&J did that. And they benchmark some other companies like Georgia Pacific, who's got a digital transformation practice that's very provocative and thought-invoking. And work together. Don't try to do this alone, because it's new for everybody. And there's some people that are ahead of other people. And if you're not a competitor, they're willing to share.
So let me ask. Let's drill down into your application.
Okay.
You're inspecting a pharmaceutical product of some sort. What sensor, what data do you collect and contrast to determine what's good or bad? Is it visual? Is it a camera?
It's a camera. Yes.
It's a camera. So what happens? Is it just a visual matching system, or for the uninitiated? To me, I think. So do you know it maybe be a visual matching system. I'm thinking about what about other defects that are unseen by a camera, so internally or otherwise? Yeah, so we can only do what we see. That's the whole purpose. Okay. And so their spec was 0.15 millimeter. So we can see smaller than that with a higher resolution camera. So the size of the defects, we can get very small. In electronics, we're going a lot smaller than that. So the size of the defect is dedicated. It just tells you what resolution camera you need, and at what distance you are above what you're inspecting. It's just straight physics. And then we use convolutional neural networks, machine learning, if you will, deep learning, to train our algorithms. So there is a lot of math in there. But again, we are using, the math is the hard part for most people so scaling it. Georgia Pacific and Johnson & Johnson and a lot of these companies, most that I know, have a corporate data science team, but they don't have data science teams in the factory. Right. Because data science are hard to get, and they don't want to work in Muskogee, Oklahoma. Mm-hmm. It's as simple as that. And so how do you scale your data scientists? That was one of the problems. That was when we went in with J&J, that was one of the problems we had to have. Right.
So how do you scale people who work at corporate but need to look at stuff that's out in the factory? So I can connect my appliance and let corporate look at all the pictures because I'm networked. So I can now have all their data scientists remote into my tools and do data science if they wanted to do. Let's say they wanted to do something different. It's a tool that they can use to go do that, and they can stay anywhere in the world. So we did this during COVID, and that's why we have an autonomous tool, is because we were not allowed to go into the factory. Our engineer at J&J was not allowed into the factory. It was that difficult. So it was literally, when we shipped it, it was a moon launch. We'll never touch it again. So we have to do everything autonomously or remotely.
So walk me through I have a very accurate camera.
Yep.
And I take two pictures, and one is approved, one is disproved.
Mm-hmm.
I can imagine a very simple scenario. I have a pixel. I have a count of pixel by pixel, X and Y axis. A very simple mathematical function would be if a certain number of pixels don't match the good picture, then it's a reject. What type of next step mathematical functions might be applied to those two images to define that one is a reject?
So a reason for the data scientists to go in is they have a different SKU. They have a new product, and they have to retrain a model for the new product.
Okay.
So that's really, once I've got a model trained, I don't really need to do much. It might migrate a little bit, and I have to look at it occasionally and maybe retrain it occasionally, because it's kind of a weird dynamic of AI is the models can migrate, can move over time, because they're continually learning, and you have to make sure they're going in the right direction. So there is a supervisory role that we play as these models work, but you automate that. So we're automating that.
But I'm trying to really drill down to the core of what's magical about that AI mathematical function, because I could in my vernacular approach to this, I can see a digital image
Mm-hmm.
of 10,000 pixels
Mm-hmm.
by 10,000, a matrix, and another picture 10,000 by 10,000 of an almost identical product, but a region. One pixel is different.
Mm-hmm.
I could create a very simple model that says if one pixel is different, I reject.
Okay.
But I sense it's not as simple as that.
Yeah, because you're going to get the images are on a conveyor belt that's moving, so they're not blister packs. So you might have a blister pack here in your image, or you might have a blister pack here in your image. So your model wouldn't work because it's not perfectly in the middle. So in the old AI world, they did exactly what you did. It's rules-based, it's Windows-based, and they say this has to be 2 millimeters this week, 3 millimeters, and it's all calculated out that way. And someone has to go in and program it. That's absolutely not what AI is.
So that's very valuable for our listeners. So the mathematical model may actually define the legal approved shape of a Band-Aid, or something like that.
The state of the state is the whole industry is trying to understand why the model predicts what it predicts. And the government is pushing this because to use in defense, you have to have that rule, whatever you want, that requirement. Right now, these models train themselves, and we can test them and know how accurate they are. We don't really know. We know why they're going through the loops, but they're going through these loops trillions of times. So the trail back of why the decision was actually made is still a work in progress. We'll probably have that out in a couple of years. Intel has a whole team working on it because some industries will require that. Automotive requires that for certain use cases, but we're not there. CNNs are just not there.
You're very likely to apply AI to the timestamp changes in the output to determine how that got to its point. It must be incredible amounts of data if you're doing it. To
understand why the model decided to say this is good or why the model said it's bad, you go through the model and you see all the different loops it goes through to calculate it, and then you have to put vectors on them and understand what were the key vectors that made that decision. And that's what the work they're going through now, because it's just new work, hasn't been done.
It just sounds like an incredible amount of work, because every iteration happens how quickly?
I don't need picoseconds.
Right. And you might be talking about a month's worth of data.
Yeah.
Times a couple of vectors. Times
Boom.
So it's not a trivial situation.
No, it's just that when we were building out AI, no one had asked the question, why is it doing this? And now that someone asked the question and it has economic value, someone's going to answer that question.
You can certainly see where someone would ask for the documentation. How do we get where we are?
Yeah, absolutely.
That's fascinating.
But I can, for inspection, I can prove that I'm 99.999%, and I can repeat that proof. Just give me, put samples under it that you know are good and bad. And so we can show you how accurate we are. We just can't tell you why.
Okay, so that's so far this has been very enlightening. What are the obstacles to AI today?
Getting data scientists, and a big obstacle. Here's a big obstacle: making the decision for what hardware you want to buy, if you're going to buy hardware. So I was talking to Ford. I was up at Ford talking to Ford, and they're 3D printing, machine vision, autonomous driving, robots, everything. Ford's doing all this kind of work above Dearborn at the Advanced Manufacturing Center. And I was talking to one of the engineers there, and he's like, you got these tensor chips with Google, Facebook's building chips, AMD's better than what's NVIDIA? I don't know what to buy right now. And this is a serious engineer that has been doing machine vision for 30 years. He's like, it's risky. And so that's a concern. Do I want to spend money today and not get it back? That's a big push for the cloud, moving it to the cloud as opposed to buying it yourself. So that's one of the obstacles is it's confusion. AI hasn't been offered as a solution. It's been piecemealed.
Well, it's interesting. I mean, you're going very quickly through this, but let's back up to simply the data set.
Yep.
That's not a trivial that's not a trivial piece of work to go and try to assemble all that data, catalog it, label it, organize it, and have it to be operated on with any mathematical function. You forget if it's even AI.
In a brownfield, absolutely.
That's a challenge in itself.
Yep.
Then we have, particularly in the challenging environment we live in, there are only so many data scientists, and it's a very tight labor
hard to
market.
get. I got job openings.
There's only so many. And that last one, what chipset do you pick?
Yeah.
And I'm sure each one has its advantages and disadvantages.
And what's coming out next year? There's so many difficulties in it. It really depends on what your skill set as a company. What do you want to be when you grow up? Because remember when we first did ERP systems? I have gray hair. And the cost of the ERP system was irrelevant. I remember when Coke did an ERP system globally, they gave Ernst & Young $300 million to integrate it. And then what everybody realized after that first iteration of ERP is don't customize anything, because you can't, once you've customized it, you own it, you're now a software company. And so that's the decision you're making. I mean, do you want to be a software company? Do you want to be a hardware company? Or do you want service providers to provide it for you?
Indeed. Can a end user today work backwards and say, hey, I've got, here's a challenging problem that I would like to solve, and it's arguably maybe unsolvable by any solution other than an AI-based solution? Do then end users go and say, listen, okay, let me go out and pursue an AI-powered solution to solve that previously unsolvable problem? Do you see people starting to do that?
Well, that's what we're doing with Johnson & Johnson. We're using AI to do inspections.
Exactly.
So that's for the problems that you have, pick your biggest problems. I would absolutely talk through it with industry peers and data scientists, say, is this something that AI could help with? So it really depends on what the set of the problem is. But what are computers really good at? They're really good at 100% focus. It's like, the kid's book, Where's Waldo?
Yes.
So the computer can go through that book of Where's Waldo before you can open the book. Literally, by the time you've opened the cover, it's finished it. It's really good at finding minute little things. So there's some skill sets computers have that we as human beings don't have. So if the problem involved looking at a lot of stuff and coming up with a creative solution to it, don't give it to AI. AI won't work there. That's what humans do. If it's a mundane, repeatable task that you're doing a lot, AI will solve that. If it's mundane and if it's a task that you think is mundane and repeatable and you don't like doing it, give it to AI.
Like perhaps driving your car.
I like driving my car, so I don't want to except at certain times. But yes, exactly. When I'm in traffic, I don't want to drive my car. I have a stick shift. No. So yes. So yeah, mundane tasks. Give them, at the airport, the trains moving back and forth. They're things that computers do incredibly well.
That's very good. So what do we see for the future?
So I believe AI is going to go everywhere. AI is just math. So a lot of people are putting a lot of value in the IP behind the algorithms. I know some of my ex-companies are doing that. Good luck. It's just math. If I can solve a math problem one way, I can solve it another way. So what's the IP? And if you have IP, what if I put it through a Laplace transform? It's now mine. Huh? What do you do then? So I don't know. I'm not a lawyer. I don't like paying lawyers. But I don't know how you patent math.
That's true. It's maybe at most a copyright issue.
Maybe you could do a copyright.
Maybe,
I don't know.
Maybe. But you change a little bit.
Exactly. I'm not copywriting it anymore. It's going to be there's going to be a lot of money litigated.
And that's that. What else have we not covered? We're nearing the end of our time together. What other messages might you have for our audience? What calls to action might you have?
I think these are the most exciting times to be in the industrial sector. If you were an engineer, you probably your whole career been asking for a budget and not got one to do automation or to do any of these kind of things. Your board of directors is now setting aside money to do sustainability, to do IoT, to do AI. The board of directors is giving you a pot of money. So this is new in your career. Be smart, benchmark with people that are ahead of you. Look to peers, go outside your industry. Obviously, don't go to your competition. Look at the people. Go talk to Intel. I'm not kidding you. Intel will talk to you. Very few people compete with Intel, and very few people actually buy from Intel. And they've got a digital story because they had to build those chips.
Incredible story.
So it's great times. If you're an engineer and an industrial, this is the gold times, the gold standard.
Well, I thank you for joining us today.
Thanks for having me.
Ted
This is a great
Connell
conversation.
Again, my guest was Ted Connell of Blue Skies AI. Ted, before we go, can you share your contact information if someone would like to speak with you?
Yeah, absolutely. It's T Connell, Connell, at blueskies.ai, and my phone number is 480-797-3570, and our website is blueskies.ai.
Well, once again, thanks everybody for joining us on this edition of the Smart City Podcast, and thanks again to Ted and our audio engineer, Tom Cabot.
Thank you,
Tom. Take care. We'll see you guys again.
Cheers.
Broadcasting from Boston, Massachusetts, the Smart Cities Podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.